So in example 2, there are basically 4 parts to this question. We're dealing with a survey of 1,024 registered voters, 512 plan to vote for the Republican candidate. And we want to estimate P, which is the proportion of all voters who plan to vote for the Republican candidate. So what we always start with when we're estimating a parameter is we always start with the statistic. And part 1 asks you to calculate that statistic of P hat, which is the sample proportion. So the sample proportion is there are 512 people out of the 1,024 who plan to vote for the Republican candidate. So that is 0.5, or if you want to write it as a percent, that is 50%. Question 2 asks you to calculate the margin of error. We did this back in chapter 3, so it's been a while, but we took 1 over square root of n. N in this case is 1,024. So if you take 1 over the square root of 1,024, in this case you will get 0.03125. So basically we get about 3% of error. So if you remember back in chapter 3, if we have 3% of error, that means we're essentially 95% confident that the population proportion here is between 47 and 53%. Remember, that's 50% minus 3% and 50% plus 3%. That gives us that plus or minus 3%. If you look back in chapter 3, you will see that. The third part of this question says to calculate the standard deviation for the sampling distribution. So notice in this case, we're going to take p hat, 1 minus p hat over n. So notice what I did here. We don't have an exact value for p because that's what we're trying to estimate. So instead of plugging in p into this equation, notice that I plugged in p hat, and that is a common thing to do. I'm going to estimate p by p hat, so I replace p in the formula with the p hat value. So we just said that p hat is 0.5, so that's 0.5, 1 minus 0.5. And that's over my sample size, which is 1,024. So you essentially get 0.25 over 1,024. You divide that, take the square root, and you will get 0.015625. So that is what you end up with your standard deviation. And then part 4 talks about the empirical rule. The empirical rule says that 95% of your data will fall within 2 standard deviations. So since that is the case, first keep in mind that we're dealing with 95%, which is what the margin of error indicates. We're 95% confident that we're within the margin of error when we use 1 over square root of n. So if we take 2 times this standard deviation, or 2 standard deviations, what you'll notice is you get 0.03125, which is exactly what we said the margin of error was. The margin of error formula, 1 over square root of n, comes from this idea that we're taking 2 standard deviations because that gives us 95% of our data. 95% of p hat values are within 2 standard deviations of p. 2 standard deviations in this case is 0.03125, and that is where that margin of error comes from. It comes directly from the variability in your sampling distribution. That is what all of these confidence intervals are going to be based on, so it's important that you see that. It comes from the variability in your sampling distribution. That's where you get margin of error.